All right, welcome to The Explainer. Today, we are tackling a huge topic, something that's totally changed how modern software gets built. We're talking about microservices. So have you ever wondered what the secret sauce is for companies like Netflix or Amazon? I mean, how do they push out new features all the time on these gigantic apps without the whole thing just collapsing? Well, there's an answer. It's a revolutionary architectural style. And trust me, by the end of this, you're going to get it. Okay, so to really get our heads around this, let's use an analogy. And we're going to stick with this one. Think about it like a restaurant kitchen. The old way? That's the monolithic monster. Picture one single, totally overwhelmed chef. They're trying to cook every single thing on a huge menu in one chaotic kitchen. Now, the new way, the microservice way, that's a team of specialist chefs. You've got your grill master, your pastry chef, your bartender, each at their own clean, independent station. This whole kitchen idea, it's going to be our guide through this whole thing. So before we get to the solution, let's really dig into the problem we're trying to solve here. For a long, long time, software was built as this one giant single unit. We call it a monolith. And, as these things got bigger and more complex, they started causing some major headaches. And these headaches, they map perfectly back to our chaotic kitchen scenario. Think about it. If our one lonely chef wants to change just one tiny thing, like the soup recipe, they have to shut down the entire kitchen to do it. That's a full system rebuild. And what happens when the dinner rush hits? You can't just add a grill cook. Nope, you have to build a whole new identical kitchen. It's all or nothing and super expensive. And if the deep fryer breaks, the whole restaurant closes down. You can see how updates in a monolith become slow, super risky, and honestly, pretty terrifying. Okay, so how do we get out of this monolithic mess? Well, the industry came up with a much smarter approach. Instead of building one giant, tangled block of code, you break it up. You build your application as a collection of small, independent, focused services. And this is the absolute core idea. A microservice, it's just like one of our specialist chefs. The pastry chef, they only care about desserts. That's their world. They have their own flour, their own ovens, their own tools. They can whip up a brand new cake, and the bartender, over in their own corner, doesn't even know or care. Each service is built to handle one business function, and to do it really, really well. All right, so you might be thinking, a kitchen full of specialists sounds great, but how do you keep it from turning into total chaos? And that's a great question. It turns out there are some really important rules of the road, some core principles that every one of these services, every chef, has to live by. The real secret sauce here boils down to these rules. First, they're self-contained. The grill chef has his own grill, his own tongs, everything. He's not sharing with the pastry chef. Second, they're implementation independent. This is cool. The grill chef might use a charcoal grill, a specific programming language, while the pastry chef uses a high-tech convection oven, a totally different language. And this one is huge. They're independently deployable. The pastry chef can roll out a new dessert right in the middle of dinner service without stopping the whole kitchen. And finally, they're business-oriented. The bartender's job isn't a technical task like pouring liquids. No, their job is the business of serving drinks. It's a really important distinction. All of this really circles back to a foundational idea in good software design, the single responsibility principle. It sounds super simple, right? Each component should do one thing and do it well. But here's the catch. Defining what one thing actually is, that's the hard part. And this is where a lot of people get tripped up. Single responsibility doesn't mean a single action. It means responsibility over a single business asset or capability. Let's take a password manager service. Its one thing is managing passwords, period. But that responsibility includes creating new passwords, checking existing ones, and handling resets. Now, if you broke that up into 3 tiny services, one for creating, one for checking, one for resetting, what happens? They all have to talk to the same password database. And boom, you've just created the exact kind of messy, tangled dependencies you are trying to get away from. Okay, so that's the theory. That's how it's supposed to work. But what's the real-world payoff? Why on earth would a company go through all the trouble of setting up this fancy, specialized kitchen? Because the payoff is huge.
This is where the model just absolutely shines. Back to the kitchen. Happy hour hits and the bar is slammed. What do? You don't build a whole second restaurant. That's insane. You just add a second bartender. That's targeted, cost-effective scaling. The pastry chef wants to launch a new dessert? Do it in the middle of dinner service. The grill chef won't even notice. That's faster, safer deployment. The bartender wants to experiment with some wild new cocktail-making tech? Go for it. It doesn't affect anyone else. That's freedom to innovate. And maybe the most critical part, resilience. If the deep fryer breaks, so what? You can still get a steak, a drink, and a dessert. The rest of the system keeps running.
But, there's no such thing as a free lunch. This all sounds amazing, but managing this team of independent specialists, well, it's not as simple as just telling one chef what to do. This approach introduces a brand new set of challenges, and they all revolve around coordination. So how in the world do you get all these different chefs to cooperate to make one customer's dinner? Well, there are two main ways to think about it. First, you have orchestration. This is like having a central head waiter who tells each chef exactly what to do and when. It's straightforward, easy to track, but that head waiter can become a real bottleneck. The other model is called choreography, and this is more like a dance. There's no conductor. The grill chef finishes the steak and shouts "order up," and the sauce chef hears that event and knows it's their turn. It's way more flexible, but if someone misses their cue, it can be a nightmare to figure out what went wrong. Okay, another massive challenge. What happens when things break? Let's say the pastry chef's station gets overwhelmed and just stops responding. In a simple system, every service needing a dessert would just wait, grinding everything to a halt. This is where a pattern called the circuit breaker comes in, and it's brilliant. After a few failed requests to the pastry station, a circuit breaker trips open. From that point on, any new request for dessert fails instantly. The system says, nope, don't even bother asking. This is so important because it stops one broken service from causing a catastrophic, system-wide slowdown. And now for maybe the most brain-bending challenge of them all, data. If every chef has their own separate ingredient list, how do you keep them all in sync? The answer is a concept called eventual consistency. It's a promise that if things quiet down, all the separate databases will eventually match up. That key word, eventually, is everything. It means for a period of time, things might be out of sync, and your system has to be built to handle that. It's a fundamental trade-off you make for all those other benefits. All right, let's pull this all together. Microservices are small, independent services, each with a single responsibility, like our specialist chefs. This architecture is what enables that amazing scalability, rapid deployment, and freedom to innovate. But remember, you're trading the problems of a monolith for new challenges in coordination and data consistency. The most common way they talk is through RESTful APIs. And to keep it all from falling apart, you absolutely need smart failure management patterns like the circuit breaker. So there you have it. This architecture is, without a doubt, the engine that powers so much of the modern internet. But as we've seen, all that power comes with a price tag of complexity, which leaves us with one last, really important question to think about. When you're building something, is this incredibly powerful but also complicated architecture always the right choice? Something to chew on. Thanks for joining me.